Hello everyone, this is MOHAMMAD ASAD AMIN, lecturer in Physics, Education and Literacy Department. Today I will deliver you a lecture on a topic Newton's rings from chapter number 9, first year physics. I hope you will find this lecture interesting and informative. Newton's rings and formation of Newton's rings. As you see in the diagram that when a plano-convex lens with its convex surface is placed on a glass sheet, an air film of gradually increasing thickness outward is formed between the lens and the sheet. The thickness of the film at that point of contact is 0. Now when this light is incident, so this incident light is divided into two parts. The first part is reflected from the upper portion of the film, and the second part is reflected from the lower portion of the air film, which is formed between lens and glass sheet. Now when these rays refracted and interfere with each other, so because they belongs to the same source of light, so they are phase coherent, they are having same frequency and wavelength, so they interfere with each other and bright and dark alternate rings are formed, which are termed as Newton rings. Now as you see in the second diagram, it can be more clear practically that whenever a monochromatic source of light is placed in front of a lens L and this source is illuminated, so the two light waves or rays after passing through the lens would become parallel, and when they strike the glass sheet, which is placed at an angle of 45 degree, so these two light rays are reflected at an angle of 90 degree and interfere with each other, and this interference will cause concentric bright and dark rings which can be seen through a microscope. These rings are termed as Newton rings. Now here we will discuss what really happens. Actually, Newton rings are formed due to interference between the light waves reflected from the top and bottom surfaces of the air film formed between the lens and the glass sheet. As I explained you that whenever you placed a convex lens on a glass plate, air film is formed. An air film of varying thickness is formed between the lens and the glass sheet. When the light ray is incident on the upper surface of the lens, it is reflected as well as refracted. When the refracted ray strikes the glass sheet, it undergoes a phase change of 180 degree on the reflection. Now you can understand this thing as that when light wave strikes a surface which is of high refractive index, then it always get a phase reversal of 180 degree, and this is the main cause of the formation of Newton's rings. Due to phase reversal of 180 degree, the condition of interference in case of Newton's rings is reversed. Now you have already studied in the Young double slit experiment that for constructive interference we take part difference equals to m lambda, but here interference occurs between the two waves that interfere constructively if part difference between them is m plus half into lambda, and destructively if part difference between them is m lambda. This shows that the condition of interference in case of Newton's ring due to phase reversal of 180 degree is reversed. Now in the second diagram you can see the ray of light 1 which is reflecting from the surface A of the air film, and the second is reflecting from the lower surface of the film, and these two rays interfere according to the condition of interference and form alternate bright and dark rings. Now we will derive a formula for radius of nth bright and nth dark ring. So for this we consider a plano-convex lens which is placed on a glass flat surface or a glass plate. Let the radius of curvature of convex lens is capital R and radius of ring is small r. Wavelength of light which is used here is lambda. Now you see there is a formation of a air film which is of thickness T taken from point A to point B. After reflection and refraction, two rays 1 and 2 are obtained, as you can see in the diagram. These rays interfere each other, producing alternate bright and dark rings. At the point of contact, the thickness of air film and the path difference both is equals to 0. As a 180 degree path difference occurs, so they cancel each other because one part is reflected by 180 degree, that is the crest becomes a trough. So when the crest of one part will interfere with the trough of the other, then they cancel each other and a dark ring is obtained at the center. Let the distance from point B to point C is 2r minus t. As we move away from the central point, path difference is also changed and alternate dark and bright rings are formed. Let us suppose that the thickness of air film is small t. By using the theorem of geometry, BD multiplied by BE is equals to AB multiplied by BC. Now BD is equals to R and BE is also equals to R. So R multiplied by R is equals to AB into BC, where AB in the diagram is T and BC in the diagram is 2R minus T. So now you will get R square equals to 2RT minus T square, because when you multiply T inside the bracket you will get 2RT minus T square. Since T is very small as compared to R, therefore we neglect the higher power of T, that is T square. So now R square is equals to 2RT and R square is equals to 2RT, which is our equation number 1. Now I have already defined this thing that AB is equals to T, BC is equals to 2R minus T and BD is equals to R. Since light falls normally on the arrangement, so the first portion which is reflected from the upper surface of the convex lens curvature and the second portion which is reflected from the lower part of the glass plate is covering a more distance equal to T. So this distance will be doubled and is equals to 2T, and which is the path difference between the two rays. So now I can take 2T is equals to m plus half lambda, which is the condition of interference for Newton ring for bright ring. Now here we have taken refractive index equals to 1 for air. So actually the formula is 2nt equals to m plus half lambda, but n is equals to 1. So this would become 2t is equals to m plus half lambda, which is our equation number 2. For first bright ring we take the order equals to 0. For second bright ring we take the order 1. For third bright ring we take the order 2. And for nth bright ring we take order equals to n minus 1. Putting the value of m in equation 2, we get 2t equals to n minus half into lambda, and from here t is equals to half n minus 1 upon 2 into lambda, which is our equation number 3. Putting the value of t in equation number 1, we get r square equals to 2rt, and r square is equals to 2r into half n minus half lambda, and r square is equals to r into n minus half lambda. Rn, that is radius of nth bright ring, is equals to under root r lambda into n minus half, which is the formula for radius of nth bright ring, where n is the ring number, capital R is radius of curvature of lens, and lambda is the wavelength of light. Now for dark ring, we will take part difference 2t is equals to m lambda. Now here the order is equals to the number of dark rings, because the condition of interference are reversed here, and for dark ring or for destructive interference the order m is equals to n. So 2t is equals to now n lambda. Now as you know that r square is equals to 2tr, so r square is equals to rn lambda. If you put the value of 2t in this equation, you will get r square is equals to rn lambda. Squaring on both sides, you will get r is equals to under root r into n into lambda, which is the required equation for the radius of nth dark ring.